of equations algebraically. All right, our first example. So we're given two parabolas. And when it's to solve the system of equations, we want to find out how many times do those two parabolas intersect, and then where do they actually intersect. So for instance, you don't have to draw this, but I want to give you an example. Maybe we have one parabola that opens up and another one that opens down. Do these two parabolas ever intersect? So they'd have no solutions. Or maybe we have one that opens up and one that opens down, but how many times do these intersect? And if this was the case, we would want to find out these exact intersection points. And the intersection points have both an x and a y coordinate. Or maybe it's possible they intersect just once at one point. Or it's actually possible that they coincide, meaning one parabola is directly over the top of the other, and they have infinitely many solutions. So that's visually what it looks like, but we are going to solve algebraically. So to do that, do me a favor and circle what each equation has. So y equals, circle y equals, and circle. I'm going to take these two portions and I'm going to set them equal to one another. Okay, now I'm going to combine like terms, and there's no wrong way to do this. I can move everything on the right to the left or everything on the left to the right. There's no wrong way. I personally would prefer to move, in this case, everything on the left to the right. And the reason I would like to do that is then when I move this negative 5x squared over, it becomes a positive. So that's my reasoning, but you can move either way. So when this moves over, it becomes positive, and it cancels. And when this moves over, I'm going to add it. And when this moves over, I'm going to subtract it. So everything has canceled out on the left-hand side. And now on the right-hand side, I have 6x squared plus 10x minus 4. And we have a few different ways we can solve. And it's really up to you on which method you prefer. We can solve in one of these three ways. You could always use the quadratic formula. That works every time. You can always use completing the square. And when it's factorable, you can factor and solve. But remember, not all quadratic equations are factorable. So I believe it's always easiest to first see, hey, can we factor? Because if we can, the process is going to be a little bit quicker. So let's check. 6 times negative 4 is negative 24. Can we think of two numbers that multiply to get an answer of negative 24 but combine to give you positive 10? And we can. It would be positive 12 and negative 2. Then I need to take the 6 and put the 6 underneath and reduce if possible. So as a reminder, quadratic formula and completing the square are two methods that will always work to solve. Factoring to solve only works when you can factor. In this case, we can. So let's circle the positive 2 and circle the negative 1/3. X equals negative 2 and x equals positive 1/3 are two answers. That means there's two places where the parabolas are going to intersect. So if I was going to look up here, it would resemble something like this, but in this case, we don't have one parabola that's going downward, but it will resemble a situation when you have two parabolas and they intersect at two places. Okay, so remember, each one of these places has both an x value and it also has y value. So I only have the x values. All right, so now it's going to say for your test or for your quiz you have to show work. So here's how you're going to show work next. Look up above. Which equation appears to be easier to work with, the top or bottom? There's no wrong answer. I would guess the bottom. Just seems like smaller numbers. So I'm going to write down the bottom of the equation, but wherever I see an x, I'm going to substitute in -2. I'm going to do the same thing over here again. And then we're going to let the calculator do the hard work. So I'm going to start with this problem. Again, I chose one of the two original equations, and I'm substituting the value of -2 for x. Okay, plugging into your calculator. 1 parentheses, -2 in parentheses squared, plus 5 parentheses -2, subtract 2. -8. Can somebody confirm you get the same answer? Okay, so write y equals -8. All right, these two go together. So one coordinates where the parabolas intersect is -2, -8. That's one answer. I'm going to do the exact same thing, plugging in 1/3. So 1 parenthesis, 1/3 squared, plus 5 parenthesis, 1/3 minus 2. If it's a decimal, we're going to turn it back into a fraction. So I'm hitting math, fraction, enter, enter, and y equals -2/9. The coordinates of the second intersection point is 1/3 and -2/9. These are the two answers, two final answers. The biggest mistake students make is they come up with two x values and then they stop. Or they come up with one x value and they stop and they forget to get the corresponding y value.